Hey, this is your teacher, Ms. Lala. Today I'm going to be teaching you how to solve systems of equations in 3 different methods. We can solve by doing graphing, we can do substitution, and we can do elimination. So first I'm going to start with graphing. So if you notice, this equation is already in what is called slope-intercept form, where you have y equals your slope, which is the 6, and then the negative 11 actually represents your y-intercept. If you notice on this one, we don't have y equals. So we need to do that, has to be our first step, which is to change this equation, which is in standard form right now, and change it into slope-intercept form. So I'm going to teach you how to do that. So we have negative 2x minus 3y equals negative 7. So the purpose is to isolate y, to get y by itself. So we need to do the inverse operation of all the other terms. So the first term we're gonna take over to the other side of the equal sign is the negative 2x. The inverse of that, the opposite, is to do plus 2x. When you do plus 2x to one side, you always have to do it to the other side to keep your equation balanced. So now we have plus 2x on both sides. So after that, these will cancel because opposites cancel each other out, and then you're left with this, which is negative 3y. Then this is all one problem, so we have a positive 2x minus a 7. This negative 7 is the same thing as saying minus 7. So now we need to get rid of this negative 3, so the y could be by itself. The negative 3 is multiplying itself with y, so the inverse operation would be to divide. Whenever you divide by the same integer, which is a negative 3. And now you got to do it to each term. So divide by negative 3 here and divide by negative 3 here. So these 3's will cancel. And now our final equation is going to be in slope-intercept form because it's what we wanted. It's going to be y equals 2 over negative 3 is the same thing as putting the negative on the top. So that would be negative 2/3 x, which is your slope, and then a negative divided by negative, that's positive. And then you can say 3 goes into 7 2 times, and we have 1 left over 3. So now our y-intercept is going to be a positive 2 1/3. So now your line is in slope-intercept form, which is what we wanted, and now we can graph it. So now the point is to graph that line. So we really didn't do anything to the line. It's still the same. Anything to the equation is still the same equation. By doing the inverse operation and moving things around and doing them correctly by doing the opposite, then you're really not changing anything in the equation. So now the point is to graph this equation and then graph the first equation that was already in slope-intercept form and to see where on the graph do they intersect. And if they do intersect, then that's their solution. Sometimes lines can cross intersecting one time, so that means one solution. Sometimes the lines never cross, which means they're parallel lines, so that means no solutions because they will never intersect. And then sometimes the lines are equal to each other. They're the exact same equation, they just look differently, and then when we move things around, you realize that it was the same one. Those lines are, since they're equivalent, they will overlap each other, so the line will be on top of the line, and that means many solutions. So in this case, we have 2 different equations, so they're not gonna overlap. So now I'm gonna use another whiteboard so we can graph that. So our first equation, let's start with the original one. The y equals 6x minus 11. So to graph that, we're gonna do a quick graph right here. So this line that's vertical, that's always your y-axis. And then we have our horizontal line is always your x-axis. So whenever you want to graph, you want to do that. Then on the center, we have our 0. And then to the top of y, we have positive y, 1, 2, 3, 4, 5, 6, all the way to infinity. To the right, we have all of our positive x. And then to the left, we have our negative y's. And then to the bottom, we have our negatives. So if you notice, this negative 11 is called a y-intercept. So that is the first point that you need to graph. So negative 11 on your y-axis, that's why it's called the y-intercept, is to the bottom. So I actually don't think 1, 2, 3, 4, 5, 6, 7, 8, 9. I don't have enough. Okay, so I had to reconstruct my graph because I needed negative 11 on the y-axis, which is 11 to the bottom. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So your y-intercept goes on negative 11 on the y-axis. That's the first point. And then if you notice, your slope is 6. So slope represents rise over run. So since it's a positive 6, we're going to travel 6 up, and then on the bottom there's a 1 denominator that always makes you go to the right. So we're going to use our slope to graph our next point. So 6 up, 1 to the right. So this is how you're going to jump. From the negative 11, we're going to go up 1, 2, 3, 4, 5, 6, 1 to the right. And then put a point right there. And then you could do another one. 1, 2, 3, 4, 5, 6, 1 to the right. And you could even keep going. 1, 2, 3, 4, 5, 6, 1 to the right. So you really just need 2 points to connect. But it's always better when you're doing systems of equations so you can see exactly where your lines are going to intersect. So now it's very, very important that you use the ruler to connect these because you want your line to come out as straight as possible so it can be clear the point of intersection between the two lines. Because remember, we still have to graph the other line to see where is it that these lines intersect, if they even intersect. So there's my line. I connected my points. Okay, that was our first equation, y equals 6x minus 11. The other one, we have a y-intercept of negative 2. So I'm going to do that line in green. So positive 2 and 1/3. So that means it will be a little 2 up and then 1/3. So if I was to cut up that into 3 equal parts, it would be around here. So after we do that, now we're gonna graph our slope. So now from there, you have to jump 2 down because if you remember, our equation was y equals negative 2/3 x plus 2 and 1/3. So we already graphed our y-intercept of 2 and 1/3, and now we have to travel our slope. Our slope says go 2 down, 3 to the right. So from here, you need to make sure you jump, since we're at thirds, we need to jump to the other 1/3 of the other one so it can be 1 full unit down. So that'll be 1, 2 down, and then 3 to the right. 1, 2, 3. So that's about here. So if we notice, we found our point of intersection. I could keep going and doing more points, but if you notice, we're already going to see where it's going to cross, so I really just need to do 1 point. Now, if I was to connect that, we would have our systems of equations, and it is very, very clear where they are intersecting, sorry. So there's one solution because they're intersecting at one place, and that place is at positive 2 for x and positive 1 for y. So that is your solution. Your solution is the order pair 2, 1, because that's where your lines intersect. And that's how you solve systems of equations by graphing.